Hi guys, welcome back. Today's topic is connected components. I'll discuss with you what are connected components and how to find out connected components from a given graph. Okay, so what are connected components? In a graph, connected components अगर आपको define करना है, then you can say set of vertices which are reachable. Okay, or you can say connected component is a subgraph in which any two vertices are connected by paths and no vertices is connected with any other vertices in the supergraph. Okay, let us take one example. Suppose this one is a graph. You just by looking in this graph, you have to check is everything connected, or you can say every node is connected with each other. Yes, every node is connected with each other. So this graph is having only one connected component. Okay, and let us suppose we have this graph and now this one is our graph. How many connected components are there? Is every node is connected with each other? Yes, every node is connected with each other. Okay, then this graph is having only one connected component. Now let us suppose we modify this graph and we delete this edge. Now this one is our graph. Fine. How many connected components are there? By looking at this graph, how many connected components? Is everything connected? No, everything is not connected. See, this one, this one, this one, this one, these 5 nodes are connected. So this is one connected component. Now we have these two nodes also, and these are connected with each other. So this one is a second connected component in this graph. As I have told you the definition, connected components is basically a subgraph. See, this one is our graph, or you can say super graph. So connected components hai, we have 1 and 2. So connected components is a subgraph in which every node, every vertices is connected by paths. See, in this component, every vertex is connected by these paths. This one, this one, this one, this one, or this one. Okay, and second condition was what? No vertices is connected with any other vertex in the supergraph. Supergraph is this one, and इस graph की कोई भी vertex connected नहीं है with any other vertex, because in supergraph we have 2 more vertices, but these vertices are not connected with these vertices. So this is what the connected component. So in this graph we have 2 connected components. Now let us suppose I delete this edge. Now how many connected components are there in this graph? We have 3 connected components. Okay, this is also known as one connected component, this is also known as one connected component, and this is one connected components. 1, 2 and 3 connected components we have. If suppose our graph is like this, this one was our super graph. So in this graph, how many connected components are there? One is this one is this one, and one is this one. 3 connected components are there. So see, this is a pictorial view. By looking at this graph, you can easily tell how many connected components are there. But in case of computer, we have to use some algorithm to find out these connected components. Okay, so what algorithms can be used? Either DFS or BFS, depth first search or breadth first search. I'll discuss with you how to find out connected components using that DFS algorithm with the help of one example. Okay, let us see. Now we will discuss the algorithm to find out the connected components in a given graph, and either you can use DFS traversal or BFS traversal. In this algo I am using DFS traversal to find out the connected components. The main funda is how many times the DFS traversal would be called, there would be the same number of components. See, if DFS traversal is called 3 times, then there would be 3 number of connected components. If DFS traversal is called 2 times in the graph, then there would be 2 connected components. Okay, like this. We will call this, suppose DFS graph from this vertex 0. Then we can traverse this one, then 2, then 3. But you cannot go further from 3 because there is no connected edge. This 3 is not connected with any 4, 5, 6 or 7. Fine. So here you have to stop. Then again DFS traversal would be called from this 4 and we can go to 5. We can traverse this 5 only. We cannot go anywhere else. Then again DFS traversal would be called from 6. Then we can traverse 6, 7 and 8 and that's it. So how many times DFS traversal has been called? That is 3 times. So we have 1, 2, 3, 3 number of connected components in this graph. Okay. By looking at this graph only you can also tell this one is one connected component, this one is second, this one is third. So let us take this example. Suppose we have this graph. This is complete graph from having vertex from 0 to 8 and graph is having vertex V and then edges, set of edges E. Connected components from a graph G you have to find out. The very first thing is assign a flag value -1 to all the vertices in the graph. In the algo also I have written the same line. For each vertex V belongs to n. Here n is total number of vertices in this graph. So n is here 0 to 8 means 9 we have, n value is 9. Flag of V would be -1. V would be from 0 to 8 and flag of 0 to 8 would be -1. In starting count value is 0. Count would be the total number of connected components. Okay. Now for int V is equal to 0 we will start, let us suppose from the vertex 0th vertex. Okay. Starting my V value is 0, V less than n. Yes, n value is 9 and 0 is less than 9. If condition is true then we will enter in this for loop. Okay. Now in the for loop what is written? If flag of V is equal to -1. If this condition is true, yes, this one is true because flag of 0 is what? -1. Yes, this condition is true. Then we will go to the if condition, and in if condition what we have called? DFS V flag. DFS has been called. Fine. So here V value is 0 and flag is -1. So this DFS would be called and the control will go to here only. This is function calling and then control will go to the function definition. Here we have defined this DFS. Int V, int flag. Here V value is 0 and flag is -1. Okay. Then what is there? Flag of V is 1. If flag is -1, after entering this function, that flag of that vertex should be converted to 1. So flag of 0 would be 1, means this vertex has been visited or traversed. Fine. 1 maybe we can say true, or here -1 is false. Okay. Now see out V, we will print this V. Finally the output would be V would be printed. The value of V is 0. Okay. 0 would be printed. Now next is what? For each adjacent node U of V. Now we will check the adjacent node of this 0. How many adjacent node are there? 1 and 3. We have 2 adjacent node. So for each adjacent node U of V, find out if flag of U is -1. Fine. We have this adjacent node 1 and 3. Let us take, we will take this 1 first of all. Now U value is what? Here we have U is equal to 1. Flag of U, flag of 1 is -1. Yes, that is -1. In that case what we have done, this condition is true, then DFS will be called a recursive. This is recursive call in this function only. Then DFS, here we will go. Fine. DFS would be called, and this one is U and flag. U value is 1 and flag is -1. So DFS would be called. Now here we have 1 and flag is -1. Now we are at this place. Again flag of V is equal to 0. Now V क्या हो चुका है अपना? The vertex 1. Now this flag of this would be 1. That is true. And see out V. Then we will print this 1. Okay. Next condition. For each adjacent node U of V. See, now V is what? This 1. Okay. And find out the each adjacent node of this 1. 1 का adjacent node है अपने पास, that 2 and 0 also. Okay. 0 and 2. For each adjacent node U of V, if flag of U is -1. Now let us take adjacent node 2. Fine. Now our u becomes 2. Flag of u. Suppose we are taking adjacent node u is, suppose we are taking 2, now u is our 2. Flag of 2 is -1. Yes, this is -1. In that case, again DFS would be called. Here, what? Now we have u value 2 and flag is -1. Okay. Again DFS will be called recursively. Okay. Int v becomes what? What value would be passed? 2 and -1. Okay. Now flag of v is 1. Now here v is what? 2. This vertex 2. Now flag of this would become 1. Okay. And cout v, we will print this 2. Fine. Now suppose in this case if we have this at this place at vertex 1, so for each adjacent node u of v, you can say why we go to this second node. Adjacent node तो आपका 0 भी है ना, तो if you will go to 0, if you will take 0 as u vertex, then flag of 0 is what? -1. No, this one is not -1. Okay, then we will not call this function DFS again. Okay, that is why we will check for each adjacent node. Is 0 के लिए -1 नहीं है, then again we have one more adjacent node, that is 2. तो 2 के लिए check होगा ये. ठीक है. Now check. 2 pass हो गया, that is 2 has been printed. Now for each adjacent node u of v, now v is what? This 2, node 2. Now adjacent node of 2 is 1 and 3. Okay, suppose 1 is there, हम 1 को लेते हैं. Flag of u is, we have taken u as 1. Okay, flag of 1 is what? Is this -1? No, this is not -1. ठीक है, leave it. See, we have to check this condition for each node, for each adjacent node. Now we will check for this 3 because adjacent node of 2 is 1 and 3. Now for check for 3. Now u is what? 3. Okay. Now this one is 3. Flag of 3 is -1. Yes, this one is true. Then again DFS recursively will be called. Now u value is what? 3 and flag is -1. Again this is called. Now v value is what? 3 and this one is -1. I will go to this loop. Flag of v. Now v की value क्या होगी आपकी? node 3. Then this would become 1 and we would print this 3. Okay. Now check for each adjacent node u of v. Now v value is what? This 3. Fine. V value is what? This 3. Find out 3 के adjacent node we have 0 and 2. If flag of u is equal to -1, is there any adjacent node of 3 having flag -1? No, with this condition is not true. Okay. So now what would happen? We have checked out each, see this condition would be checked for each adjacent node. So for 2 and for 0 and for 2. We have checked for 0 also, that condition is not true. We have checked for 2 also, this condition is not true. Now the control will be out from this loop. Okay, and the control will go where the function has been called, from here to back to this point only. Okay, now again you can say this point only. Then now what would happen? Count plus plus. Count value is what? 0. Now count would become 1. Okay. Okay, count would become 1. We will be out from this if statement, but we are not out from this for statement, because here what would happen? V plus plus. So you cannot say that v would be 1. Why so? Because v is already 3. V has already been updated. V has reached to the node 3 from this function only. Now v would become what? 4. Fine. Now again check out the condition. 4 is less than 9. Yes, this condition is true. Then we'll enter in this for loop. If flag of v is equal to -1. Yes, flag of 4 is -1. This condition is true. Then you will enter in this if condition. If condition में again क्या है? We will call this DFS. Now value of v is what? 4 and flag is -1. This function will be called. The control would go to here only. Okay. Now what is the value of v? what has been passed? 4, and flag value is -1. Fine. Now flag of v is equal to 1. We will set this flag 1. Okay. Now see out 4 would be printed. Here you can write see out /n, then 4 would be printed in next line, because if 4 would be printed in this line only, then you cannot differentiate how many connected components are there and what are the vertices in that component. So better if you we write after this cout count plus plus, we write cout /n. That is why this 4 would be printed in next line. Okay. Now we have printed this 4 for each adjacent node u of v. Now here v is what? 4. Adjacent node of this 4 is 5. Now u की value अपने पास क्या है? 5. If flag of 5 is flag of u is -1, yes, flag of 5 is -1, this condition is true, then again this recursively DFS would be called, and the value of u is what? 5 at this place, and flag is -1, flag of 5 is -1. Now here 5 would be passed and here is -1, then flag of v value is what? 5, the flag of 5 would be set as 1, and see out this 5 would be printed. Again check for each adjacent node u of v. Now v value is what? 5. Now check out the adjacent node of this 5. Adjacent node of 5 is only we have one adjacent node, that is 4. But this condition is not true for 4. But flag of 4 is -1. No, this one is 1. This condition is not true. And we have only one adjacent node, so we cannot check out further. Then finally we would go back to this point and then count plus plus. And count would become now what? 2. Okay. And see out /n. Here we would go to the next line. Fine. Now see out see out /n has been printed. We are out from this if condition, but we are not out from this for loop. Again v plus plus. Fine. Then we what is the recent value of v? What has been passed back? That is value has been updated to 5 only. Then v plus plus would be 6 now. You cannot say that पहले अपने पास 4 थी, 4 से हमने स्टार्ट किया था तो 5 होगी. नो, इस फंक्शन में हमारी v की वैल्यू क्या हो चुकी है? 5. देन v की वैल्यू वुड बी 6. इफ फ्लैग ऑफ 6 is -1, yes, this one is -1, this one is true. Again we would go to this DFS. Now v value would be passed as 6 and -1. Now we would go to again here only v value is 6 and this one is -1. Flag of v would be set as 1. 6 would be printed in next line. Now check out for each adjacent node u of v. V value is 6, adjacent node is 7 and 8. First of all we will take this 7. Now first u value is 7. Flag of u value is now 7. Flag of 7 is -1. Yeah, this condition is true. Then DFS would be called and u is 7 and -1 would be passed. Here we have 7 and -1. Fine. Flag of v is 7. That would be set to 1 only and 7 would be printed. Okay. Now for each adjacent node u of v. Now v is what? 7. 7 का adjacent node है अपने पास 6 और 8. We will check for suppose 8 because 6 के लिए check करोगे this condition would not be true. Then again हम किसके लिए check करेंगे? 8 के लिए आप check करोगे. Okay. 8 के लिए हमने check किया. Sorry. In that case what would happen? Same would be 8 would be passed here. -1. Again this would be 1. Fine. And 8 would be printed for each adjacent node of u of v. 8 का adjacent node 6 and 7 है, but this condition is not true for any node. Then we would go back to this point and count would be 3. See out plus would go to the third line. Okay. Now out of this if statement, now what is value of this v plus plus? Already this value has been updated to 8. Now v plus plus जैसे ही होगा that would be 9, but 9 is not less than 9. This condition is not true. Then we would go out of this for loop. Out of this for loop. These are the bracket for for loop, and out of this for loop what has been printed, see out, count value is what, 3, then 3 would be printed. Okay, and we are out of this loop. Now how many components are there? 3 components are there. Count value is 3, so that is why we have 3 connected components in this graph. So this is how you can check out this the number of connected components in a given graph. Okay, you just take one example and trace out this example with the help of one code. Okay, so I'll see you in the next video. Till then, bye bye, take care.